This example of solving a system of equations by graphing is a special case that has an infinite number of solutions. And it may be hard at first to see how that could be, but let's take a closer look. Let's get these into slope-intercept form to graph them. So let's see, I'm going to solve this for y, so I'm going to subtract x from both sides. Negative 2y equals negative x minus 6. And then we divide everything by negative 2 to get y equals 1/2 x plus 3. Okay, so 1/2 is our slope. Our y-intercept is 3, so we can graph that. 3 is our y-intercept, and then we'll go up 1 and 2 to the right for the slope. So up 1 and 2 to the right gives us a second point right there, and we connect the 2 points to make a line, like so. Let's look at the second equation now. We'll do the same thing. Into slope-intercept form we go. So I'm solving for y. We get 4y equals 2x plus 12. Dividing by 4 gives y equals 1/2 x plus 3. Now, do you notice anything about that line compared to the one before it? Indeed. Look at that. Here's our slope, here's our y-intercept. These are the same line. When we plot this bottom line, it's right on top of the top line. There's our y-intercept, there's our slope of 1/2. Connect the dots to get a line. There we have it. Those lines are right on top of each other. Now remember, a solution occurs wherever these two lines cross. Well, these are the same two lines. So where do they cross? They cross everywhere. Thus, we say this has an infinite number of solutions, but it's not enough to just write this, right? We don't just say infinite number of solutions, because we can say more than that. We instead write this. So it's the curly brackets, and we say x comma y, vertical line, this means such that, and then we can pick one of these two lines to represent. X minus 2y equals negative 6. I'm just grabbing the top one. So I'll interpret what this means. These curly brackets here mean we're in set notation. So this is a set. And what this is saying, all points x and y, this vertical line here means such that. Okay, such that what? Such that the points are on the line. So I'll just say they are on the line. Okay, so that's how we interpret this notation. So we're not saying it's every point on the entire plane, right? It's not everywhere. It's only a specific kind of point. They have to lie right on that line. So some people are tempted to write something like all real numbers here, or write out the words all real numbers. But it's not all real numbers. It's a very specific set of real numbers. It's just the order pairs that lie on that line. An equally good way to write this could have been by taking the bottom version of the line. So we could have also said x comma y such that negative 2x plus 4y equals 12. That's just as good. So it's a little bit tricky to write the final answer once you determine that you have an infinite number of solutions, but it's not enough to just write out infinite number of solutions or just write real numbers or something like that.